Hello, Keith Rucker here at VintageMachinery.org. Guys, I got another little project. This was a little bit of a rush emergency job for the museum, and we got a broken part off of the steam locomotive out there. So if you watch my channel much, you know the museum has a 1917 built 040 steam locomotive, narrow gauge, made by the Vulcan Iron Works from Wilkes-Barre, Pennsylvania. Not the Vulcan Iron Works in the UK. There was actually one in the US as well. I get that question a lot actually in my videos and comments, so I'll clarify that. But this is a spring hanger that goes on the front of the locomotive. There's basically a little cross member that goes up underneath the boiler that connects down to some springs. There's 4 sets of leaf springs to kind of give a little suspension to the train there. And this one here, it broke up here at the top. And this is actually a repeat job for me again. This is not one that I made, but we had the same part on the other side of the locomotive break several years ago. I think it was before I started making YouTube videos. I looked last night and I didn't see where I had made a video on this before, but I have made this part before. So let me zoom you in here, show you these, kind of show you what's going on, and come up with a game plan. This is the part in question. This is, again, the spring hanger goes up on the front, and you can see we broke a little piece off the top. This part, as far as I know, is original to the locomotive. The locomotive was made in 1917, which makes this part just a touch over 101 years old. So I guess it lasted pretty well. Someone commented on my Facebook page, says, yeah, they only make those warranties for 100 years. Just as soon as it passes 100 years, you know, the warranty goes out. That's planned obsolescence. Of course, they were joking around, but lasted pretty well. I think what happens is over the years, this is obviously the weak areas up here at the top where you just don't have the steel all the way across, and it just fatigues the metal until it finally breaks. In fact, I think it's interesting to look at. I don't know if y'all can see this or not, but you can see there's a variation or a gradation of rust going across down here where you can tell it cracked. It started out about right there, and then it went a little bit deeper, then it went a little bit deeper, and went a little bit deeper. There's like a color gradient across there. And finally, at the end, all that was holding it was this little piece right here on the end. Down here, it broke, looks like sometime about right there, and then it just snapped it all off. There at the end down here. But anyway, that is what we're dealing with. I will show you this one. This is the pair, the opposite, that was on the other side that broke. I don't remember how many years ago it was. We actually walked around railroad tracks and found the little piece that broke off the top. And that is not an attempt at a repair before anybody gets on the welding job there. That is strictly just where they tacked it on there so that the parts could stay together. When anything breaks on the locomotive, we usually put the old broken part or the part that we replace in a place where we keep all those parts just as a reference for down the road if we ever need it for anything. But like I said earlier, both of these parts here appear to have been forged, which would be very typical for a locomotive manufacturer at that time. So they probably had a big, heavy-duty blacksmith working in the plant, using a big power trip hammer, and they would just forge stuff like this out. You can see on this part here, you can almost still see some hammer marks in here, right in here. In here, you can see the same thing on this. And it's interesting that these parts, not being machined and being forged, there is some subtle differences from one to the other, but they both basically do the same function and have the important dimensions that are critical. Radius on the bottom is a little bit different. The thicknesses vary a little bit. There's some variation in the thickness. But really, it doesn't matter on this part. This is just a block that goes, there's a little piece that comes through here that has a hook on it, a little cross member. And as long as you got the clearance in here, it really doesn't matter the dimensions around it that much. About the only critical dimensions that are on this is the thickness of this piece here, because it has to fit up through the spring. And then the areas for these holes here, which is where a wedge goes in. In fact, let me show you one. That's one of the little pieces that basically this fit up inside this hole. It was captured in there, and the spring rode on the top down here. And there was a similar thing down here on the bottom that a wedge would go through, and it would, actually on this there was just a hook, and it just kind of stayed on there. You'd had this little piece up here. Couldn't find this is the one off of the other side of the locomotive. We couldn't find the original of this. I'm going to probably have to make one of those as well. Now, I said this is a repeat job. I went ahead and pulled the one off that I had made before. This is the one that I machined. Again, I don't remember how many years ago it was, but I just machined it out of a solid block of steel. I didn't try forging it or anything like that. And you can see it was pretty much a copy of this one. I'm going to replicate this piece again. This is basically going to become my pattern to work off. I'm just going to work off the one that I made before. It's the same, everything. And as far as what we're going to be working with, there's my block of steel that we'll be working with. We didn't have a piece of metal this size out at the museum. It's roughly, it's a little under 1.5 inches in thickness, and it's a little under 3 inches wide. The originals here, and as is the one I made before. Looked for a piece of metal at the museum, didn't have it, so we called out to a local machine shop that we actually work with some, and they keep a pretty good supply of steel out there. They did not have a piece of bar stock. They said, you know, we'll just cut you a piece out of some 1.5 inch plate. So this has actually been, I believe that was a plasma cutter they have. They got a CNC plasma cam out there or what have you, and they just programmed that in there and cut it out. I'm a little bit concerned that, I'm hoping that I don't have any real hard edges on this where that cut was made. I'm hoping that I'm going to be able to machine those off. I know they didn't quench this after it was cut. They let it cool down slowly. And this is just mild steel, so I think that's going to be fine to make it out of. So anyway, a little bit of the history there and game plan. We're going to go over here. First thing we got to do is get this piece of metal to the dimensions that we need. And I think it's like 2.7 inches wide. And I can't remember the thickness, but again, it's just a tad under 1.5 inches. But we're going to get it all squared up. This piece is a little bit long. I'll probably next, after I get it squared up, go ahead and just rough out this piece up here, get all that metal removed, and then we'll start working on the holes in here that we'll cut, and then I'll probably just bandsaw this little extra piece down here off. I wish they'd made it just the right length, but they cut it a little bit long for some reason. No big deal, we'll bandsaw that off and get these radiuses put on there. I think last time I did these radiuses, I was in a hurry, and again, these things are not any kind of critical at all. In fact, if you look, we got a radius on this one. This one doesn't even have really a radius on it. I think I just went to the grinder and just ground those in. It was faster than trying to machine them, and I may do the same thing here. I've got that big 5 horsepower Baldor grinder over there, so I should be able to grind that off and make easy work. I'll just scribe me a line and get close to it, because again, there's nothing critical about those radiuses. They could be straight across, it wouldn't matter. This one is more or less straight across. Over to the mill. Let's get started doing some machining. I'm ready to start milling over here. I got my block in here. First thing we're going to do is get these, the width down to the right one. I need to double check. I think it's 2.70 inches. And it's not a critical measurement at all. There's a lot of variation in those over there being hand or forged pieces. It's not uniform, but that's what we're going to shoot for. That's what I made my other part at. I've got a face mill in here. This is the first time I've actually used this particular face mill. It's another one that I picked up about a year ago in an auction lot of some tooling I got from Boeing. And anyway, I'm going to give it a try and see how it works. The inserts in here are the ones that came in it, and I haven't actually gone to the trouble to figure out what insert this is and get some new ones ordered. So I'm hoping that these inserts are going to be sharp enough to do this job. They look like they're in decent shape. We'll see. And if not, I may have to switch to one of the other face mills and see about getting some ordered for this one. I'm hoping, again, this being a plasma cut surface, it's not going to be hardened and be difficult on my tooling. We're just going to see what's going on. So plan here is just get the top where it cleans up. I'll flip it over. And then we'll cut a parallel face to that and actually work on getting our thickness off of that once we get our first side cleaned up. So, turn on the phase converter. All right, American Rotary to the rescue there. We're going to set this at about, I was looking online, our calculated speeds and feeds. It said about 350 RPMs on a carbide on steel with a cutter that diameter, so we'll start there and see how that works. Raise my table up until we get a little bit of a cut. All right, let's run across there that first pass and see how she goes. I'm taking a light pass this first pass here just simply because I don't know what kind of variations across this. I don't want to get down here and start hogging. Well, it looks like we got a pretty nice finish on there. It's cleaned up just a little bit up here at the top, but I'm not worried about that. We're going to clean up later on as we do further milling on this anyway. Now we're going to flip this over and cut it to proper width here. And I will comment, I did speed my cutter up just a little bit. I think I'm up about 375. No, it's a little over 400 actually. And that just sounded better and it looks better as well. So you just got to find what works with this tooling. So let's get in here and we'll start our next step. I've got it flipped over now, and I checked my measurements. We need to be at 2.7 on the width, and we got a pretty wide tolerance there. We're currently at about 2.96, so we got over 200, almost a quarter of an inch to take off of this. Not quite. So anyway, we're just going to go ahead and start milling. Got it in here, didn't adjust the height of my machine. I got a little bit of a high spot here, so I'm going to probably just hit that first and then come back and we'll take another pass across there and chop her on down, get her down to size. All right, that first pass mostly cleaned up. We got a few little places in here it didn't quite touch, and I think we got most of that hard stuff off the top. If it's like that last side, it should start milling a little bit easier. I was throwing a few red hot chips there, so I think what I'm going to do is go get my cool mist set up on this just to get a little bit of cooling going on. I mean, this piece isn't hot at all, but by the time I mill all that off, it probably will be. So I'm going to get that set up. I'm probably not going to bore you with hogging off this metal. We'll bring you back once we get it down to size. So I'm down to my last pass here, and just get my measurements. See, we are about 19 thousandths to go on this end. This end down here, we're about 18 thousandths. So it looks like there's about a thousandths taper in there. Again, this is not a critical measurement whatsoever. So we'll just take 19 thousandths off. Let me raise this table up. All right, let's see where we're at here. We were shooting for 2-inch 700 thousandths. And again, there's no tight tolerances here required at all. And let's see where we're at. So we're about 2 thou over on that side. Again, no big deal at all. And let's see where we are down here. And we're about 1 thou over there. So again, got that about a thousandths taper in there, no big deal. We're good to go. So I'm going to take this over to the grinder, just deburr these edges. We got some sharp stuff over here, and we'll flip it over, and we got to cut our faces down, machine both of those, and get that to the proper thickness. So one more step. All right, I think we're ready to start going here. So come in here, and we'll touch off. All right. I think we'll barely touch them right there in the back. I think I'm just going on this first pass. We'll take 20. And the only reason I'm doing that, again, I don't know what kind of variations there are, and I don't want to be hogging too much. So if you look here, we cleaned up on this end, we cleaned up on this end, had a belly in the middle. So this is exactly why I didn't try to take a 30 thousandths cut. Now in this case, it wouldn't have hurt me because what's happened, or at least when I'm think has happened here is that when they cut this thing out, it was cut out on that plasma table. This piece of metal got pretty hot, and it probably has a little bit of a bow in this direction. Not a big deal. We're going to cut all this metal off anyway, and we'll get it back square. But had I started on the other side, and the bow was going up instead of down, and I started over here, touched off with a 30 thousandths cut, by the time I got to the middle, instead of, we dropped at least 30 thousandths in here, but, I might have been making a 60, 70, or 100 thousandths cut through this high spot had I gone the other side. So anyway, I just thought I would point that out. That is exactly the reason why I don't like to, on that first pass, you just don't know what you're running into. So, be a little bit conservative. Don't mess your tooling up. We're just going to go in here now, raise the table up, get this thing flat, and continue on. Second pass, cleaned it up just fine. So again, I'm going to take it over the grinder, deburr it. We'll flip it over and machine it down in size. And again, I'm not going to bore you guys with this, so I'll just bring you back when we get it to the final correct thickness. Last pass here, I just measured it. We need 25 thou to get it cleaned up. So let's take it across there and get it done. That first starts, you have an interrupted cut because the tooth is not fully engaged. Once you get in there, it sounds a lot smoother because you got multiple teeth engaged. And anyway, that's just the reason you hear that pounding when it first starts. We're ready now to kind of start our next step on this process. I've already cut this thing to length, just put it on the bandsaw, chopped it off, didn't film that. But we got to kind of neck this area down up here to make some smaller areas for it to go up in that little piece. And I've kind of drawn on here roughly my shape on the top and the bottom. And first thing we got to do is just come in here and just get this material cut out of here. I'm going to start on the narrow part, just simply because this cutter here, you can hear it kind of pounding when you don't have that full cut going between these two cutters. I mean, this is a narrow piece through here, so the wider the cut, the kind of less pounding I'm going to get out of my machine. So I'm going to cut those two, and then we'll trim the face down to the proper thickness. Get this down here. Now, as far as these 45s, I've got another little smaller face mill that has a 45 angle on it that I can kind of go in there and do that. So we'll just kind of clean up roughly to this line here, and then we'll come back and put that chamfer in there as a final step after we've got all four sides cut down to the proper thickness or width. So anyway, let's get going here. We'll get her set up in the middle to do. All right, we're set up here. Let's go ahead and touch off, and we'll start nibbling this piece out. There we go. Get some coolant going. Starting with a light pass here just to kind of get things going. What I'm going to do is just kind of work up this line and stop. And we'll come back and clean it all up later with that other face mill that's got the 45 angle on it. I'm going to purposely stop a little shy of the line. And we're going to take a full 30 thousandths pass this time. When I get down here to the end, I'm just going to kind of sweep it left or right and get me a straight line across there. And then take it back to the center. All right, so I know I've got to take about 350 thousandths off of this. So we've got about 43 thousandths to go. And this measurement is not really all that critical. These sizes here are very approximate. Remember, again, the originals were just forged out, so they were not machined. But we're going to get them as close as we can. I'm just going to dial in about 43 thousandths on my depth. And by the way, as I've been using this cutter, I've been experimenting, and I'm taking about a 50 thousandths pass right now, depth of cut, and it's cutting fine, so that's going to speed up things a little bit. Just getting to know this cutter. It's the first time I've used this particular face mill. So 43 thousandths will be the last pass here, and then we'll be ready to flip over and go to the next one. And now trim that face off. And we should be done with that one. I'm going to take this over, just deburr these edges, and we'll come back, flip it over, and do the other side. I probably won't show the other side on that face, but get it down. This needs to be about 2 inches wide when we get through. All right, we're whittling it down here. This is supposed to be 2 inches, and again, this measurement is not super critical. Let's see where we ended up at. About a thou under 2 inches, so hey, I'm very happy with that. No big deal there at all. So now we need to narrow this thickness of this down to 650 thousandths. Is what my last one was measured at. And if I did my math right, we need to take off about 365 thousandths off of each one of these faces. So we'll get this set in the vise, and same process. We'll just go in here to the shoulder, cut it down. I'm going to come back and we'll chamfer that shoulder in the next step. Blocks here to set this on. Fifty thousandths cuts have been working pretty good. We're just going to continue with that. Let it roll. Yeah, I got a much more engaged cut this time. It sounds a lot better, a lot smoother cutting than it was on that narrower face. Again, it just has to do with having that tooth fully engaged. And by the time it comes out over there, you got another tooth fully engaged on this side. So makes for a much smoother cut. All right, let's get a quick update of where we're at. We've got that little tongue down here all machined out, and we were shooting for 650 thousandths on the thickness here, right on the money. And maybe just a little bit of taper in it, but no big deal. It's right on the money there. That may just be a burr up there, but anyway, we're close enough. Like I said, these measurements are not super critical. We were 2 inches on this face. Get that chip out of there. About a thou under, about 2 thou under. So yeah, no big deal at all there. We're good to go. Next thing again is we want to put that 45 chamfer in here. I've changed my face mills out. I've got one in here that actually has a little 45 on the corners. I don't know if you can see that or not over here. So anyway, we're just going to put that in there and kind of carve that little piece out there to get what we're after. Get that little chamfer in there. So let's get this set up. All right, let's raise our table up in there. Go back across there, we're taking about a 50,000th step again. And we're just going to carve that chamfer in there. I got a little step right here where that insert only goes up so far, so we'll go down enough and clean that up as well. We're just going to blend it all in. It's not going to be a perfect, chamfer. I remember having to do this last time too. That's pretty good. We'll flip it over and just work our way around it until we get them all done. All right, so bring you in here and kind of show you where we're at. We got our piece of stock now rough milled to all the dimensions that it needs to be. And I think we're good. We got that chamfer in there. It's blended in pretty nice. It really serves no purpose other than just to give a transition zone in there. And anyway, it looks great. I'm happy with it. I think this is going to be a wrap on this video, and we're going to come back in another episode and take care of all the getting the slots put in here and rounding our corners off and so forth like that. I think we got enough content to crank one video out on this one, but I wanted to kind of give you an update on what things are looking like. Well, there you go, guys, making progress and giving the Oil Wells Index a good workout today. And we'll see you in the next episode and get this thing finished up. Hopefully get it back out to the museum and on the locomotive where they'll be back in business. Thanks for watching, guys. We appreciate it.